Namaskar, Vande Mataram. Today I am going to show you the convex lens problem as to how images are formed and how you can vary the position of the object and see how the image also varies. Now, I have taken the radius of curvature here. It's a variable thing. Then let us see, we'll draw two circles of radii r and centers at C1 and C2 to form the lens. So we'll see these circles and then we'll get this particular lens by marking the intersection of these, and then I can hide the circles. So now I've got the A and B. Now we'll draw the arcs here and we'll try to get the lens. So the two arcs I have drawn. Now I can safely hide the circle. And now C1, C2 and lens is ready. You also can do it at home, these things. Now I am drawing the center line of the lens and we mark the pole, that is the center of this particular convex lens. Now the foci F1 and F2 are the midpoints of PC1 and PC2. So we got F1 and F2. Now we'll take one object at some distance u from P, and I'm going to keep that distance u also a variable so that we can see how the convex lens modifies the images. So I am putting this object slightly beyond C1. So this is the object I have placed. Now what we'll do is we'll start rays from top of this object and see where the image would be formed. So this first ray we have drawn is parallel to the axis of the lens from top of the object. It meets the center line at D, and please note that such a ray will pass through F2 after the refraction. Okay, so now this particular ray we have got. Now we'll see the rays reflected and processed through FD. Now we'll take one more ray passing straight to the lens, no refraction, and please note that ray would pass through P. Right. And when two diverging rays pass through a lens and converge again and meet in a point, there you get the image of that particular point from which the rays start. So I am marking that. Now what we do is, in addition to this, we put one more ray. Now this ray, you will see that I have drawn it through F1. Okay, I have drawn it through F1. Now this particular ray, see, becomes parallel to the axis after refraction. and then all these rays meet in a point. Now, in actual case, there will be slight deviation between these three because of the spherical aberration. You cannot make spherical aberration absolutely zero. Okay, so I'll just summarize what we have done. We have taken the first ray, the parallel to the axis, it passes through F2. Second ray we have taken passing through pole, which moves straight. Okay. In fact, there is going to be slight deviation, but in thin lenses that deviation is not prominent. So we can take this particular ray going straight and passing through this particular point. So these two meet here, and the third ray also meets here. So this is going to be our image. Right. The image is real and inverted and is on the opposite side of the lens. So to see this image, you have to see it from here. Okay. So here you can see this particular image. Okay. Now if you keep on changing the object distance, then you will see that this diagram dynamically will change. Now let us adjust this object on C1. If you adjust that on C1, please note that the image is formed at C2. Right? I have seen one very interesting demonstration of this, that a small box, here if you keep a flower, okay, not a box, if you keep a flower here, right, and actual image is seen, and the children, they do not know these images, etc. So they feel that flower is here with the stem up, here the stem down, here stem up. So if you have it object at C, center on the other side, you will get image on this particular side. Now we keep on moving this object nearer to the lens, and you will see that the image becomes larger and larger. At one point, this ray will pass outside, but two rays will form the image. And as it approaches F, the image will go to infinite. On the contrary, if rays are coming from infinity, they will form the image at F. And that is what we get when we focus the sunlight with a lens on a piece of paper. And here, when you get the image of the sun with very high heat, because heat rays also get concentrated there, and therefore it starts burning. Now if I move this further inside, you will see that now the rays, they will, you can put them backwards, and then you see you can form the image. For that, I will push this ahead. See this. Now, these two rays, they will meet here. That means rays are in the backward direction. So we are just extrapolating these lines, and that is why this particular image is a virtual image. Where the real rays meet, we get real image. Where the extended rays meet, you get a virtual image. So see, this entire variation can be done. And this is what you use this convex lens for magnification. So I hope you can construct this at home, right? See, this entire variation can be seen.